Hello and welcome back to this phase of design thinking. This is called the test phase. But before we begin on the test phase, I would like to recap what we have covered so far. So, as we saw in the very first stages, for a long time now, we've been seeing that design thinking in this course has 4 stages. The first stage is people. Human-centered design is an alternate name for design thinking. People have a lot of places where you can help them out, you can find out what's going on with them, who you want to try and help. So, how do you really find out what people are going through? This is a method called empathize. Empathize, you get into their shoes, you get into what is really bothering them and how we can help them. So, first we find out, you can either do it through interviews, through observations. Observations are a much better way. So, once you get to know the people who are going through whatever they are going through, don't take them as the ultimate word and that is where you start, but you can apply. As design thinkers, we need to apply our own mind on what is going on. So, analyze is the next place to find out what is the problem. What exactly are people going through? Can you actually figure out what is underneath whatever experiences they are going through? Okay. So, we employed couple of methods. One was the multi-why approach, asking why multiple times to get to the bottom of it, and a conflict of interest. Usually the problem arises because of the conflict between your person of interest, your user, your customer, and something else. It could be another human being, set of human beings, or a thing, an object. So, this is now your new area of interest. So, you are going to look at this and see how might we actually solve this, which leads us to the third stage, which is solution. You do this via solving the conflict that you identified earlier stages. You come up with a lot of ideas, but again always checking back whether you are solving the problem that you started out to solve. So, that is why we have done it prior to this. Okay. You come up with a lot of ideas, the more diverse your team is, the better the richness of your ideas, the solution concepts. And a quick tip is to write it all down, so it is externalized, so that other people can see and contribute to your idea or concept. So, after we have done with solution, now is the time to go and test it out. So, that is, you develop a concept in this phase, in this stage, and that is what we are going to see now. Okay. So, this is the stage called test. Okay. So, let me start out with a story. What you see on the screen is Captain Belcher. So, he was a captain and later became an admiral with the Royal British Navy. He was around for quite a while. He was a hydrographer, the guy who used to map the seas. So, his primary job was that. So, Captain Belcher was given command of a ship called Samarang. This is a Javanese city in Indonesia. I will give you a minute to guess where this ship that you see on the screen was made. Okay. You can pause the video if you want to Google and find out where Samarang was made. Okay, yes, some of you got it. The answer is Cochin, India. It was not the UK where Captain Belcher was from, or Canada where he was born, or Indonesia where the ship was taken. Okay, so the reason I brought this story up was that this ship had a first to its name. It was the first ever ship to have what is called cathodic protection. Now, it is a complicated name for a simple concept. All ships during this time had a copper sheath underneath the ship. Now, if you put copper in seawater, it becomes corroded. What you see in iron, when you leave iron out, it develops a red powdery substance that is called rust. It is the same phenomenon called corrosion that happens even in copper. So, copper in seawater becomes corroded. Okay. Now, you might ask, let's see if you have got my course very well. The first question you would ask is, why did the copper was there in the first place? I mean, just remove that and you would have been fine. Well, the copper was in place for a reason, because the underneath the ship was exposed to marine creatures, marine life. So, a lot of creatures used to grow on the bottom of the hull. So, it was a pain for the captain like Captain Belcher, and that was not so good for the ship. So, they put up a copper sheath underneath, so that it is protected from the ship worms, as they were called, or weeds which grew underneath and affected the performance of the ship. So, that is why they had a copper sheath. But the problem was that it led to corrosion. So, at the time, now introduce our hero of the story, Sir Humphry Davy was experimenting about how to protect copper from corrosion. So, he actually had a very interesting technique called cathodic protection. It was not called that back then, but that was the phenomena that he was experimenting with. All he did was he took a cheaper substance than copper, iron or zinc, and he connected it through wires, I guess, to or just place it on top of the copper, and it took care of this corrosion problem. It would not corrode, but all the corrosion would happen with iron. Sounds like magic, that something else takes the corrosion away, and that gets corroded once that, and it is easier and cheaper to replace that material compared to copper, which is more expensive. So, he was ready, and he demonstrated this effect. He wrote a bunch of scientific papers, and everybody was happy with this. Word got around to Royal Navy, British Navy, and they said, Sir Humphry Davy, I guess he was not Sir back then, Humphry Davy's doctor, please help us with this. Lots and lots of ships are going through this, and we would like to get it fixed, and sounds like you have a solution. So, he said, yes, I can certainly test this with some of your ships. He took it to the icy waters of North Sea and applied this technique of using cast iron, which is very cheap, much cheaper than the elemental form of iron, and attached it to the hulls of the ship, the copper sheath of the ships, and it worked like a charm. Nothing corroded. It is perfect system. It really worked very, very well. Okay. So, Humphry Davy was very thorough with his experiments, and in practice it worked very well as well. Okay. So, Samarang, coming back to this picture on your screen, Samarang was chosen as the first vessel where he would apply this technique and put it in service. So, Captain Belcher was in command, and he started sailing in the warmer waters of Indonesia, tropical waters of Indonesia. So, after a while he noticed that his ship got slower and much tougher to handle, in spite of the fact that his copper was protected very well. He just didn't understand what was going on. So, he said, I have to find out, and he took it to the nearest shipyard, I guess, at the time, and found out that marine life was back in full flow. It was all around the ship's hull, and it was slowing down the ship really badly, that he could just, I mean, it was a slow tugboat after that. It wasn't a royal ship as it should be. So, he was perplexed, and he took the problem back to the Royal British Navy, and they examined it and probably took it back to Sir Humphry Davy himself, and Humphry said, oops, I guess this is what is happening, is that when you have copper, say, unprotected by our friend the cast iron, it was giving off copper ions. Copper ions are a water form of, for simplicity's sake, let us assume that these are copper particles which are let off into the sea water. Okay. Now, marine life does not like copper, it just used to avoid it. So, that is why they never got copper at the bottom of the hull when they had just copper. Okay. And now with the iron there, the copper ions were gone, and they got the marine life back. So now Royal British Navy had a tough proposition in their hand. Do I want my ship to go very fast and never mind the corrosion of copper, or do I go with Humphry Davy's solution and have beautiful copper but a slow ship? So doesn't this sound like a conflict of interest? This is what I wanted to bring up. So I have done the hard work, I have put it in place. This is the conflict of interest for you, as you see on the screen. The ship's copper hull has the variable, do I use iron with copper? So this is the conflict that is going on in the Royal British Navy's mind. Do I use iron with copper or do I not? If I use iron, then what's happening is there is no copper corrosion, yay for that. But there is marine life growth which affects my ship's performance, it's going slower. If I don't use it, now I don't have marine life under this ship, but copper is corroding like crazy. So they had to pick, instead of solving this, if you were given this problem, you would have said, I want no copper corrosion and I don't want marine life on the ship. This is what you would have said, I am sure, after my course. So this is what was missing for 100 years. This problem was unsolved for 100 years. But somebody else also tried to solve this problem. Mr. Edison from the General Electric actually gave it a shot. Why? Because somebody said, well, it has something to do with electricity, and he brought his electric solutions to this problem and tried his best to solve this problem, because there were a lot of ships that needed this fix, and so Mr. Edison was interested in solving this problem, which meant a lot of profits for his company if he did manage to solve this problem. But unfortunately, neither could Sir Humphry Davy solve this problem, and neither could Mr. Edison. So this remained unsolved for 100 years, till this whole copper thing vanished from the ship industry and from the pipe, and suddenly there were pipelines, and those are all made of cast iron, or iron. So then steel rather. So these the pipelines were made of steel. The underneath the hull of the ship was made of steel. So now the problem had shifted completely. We didn't need copper protection anymore, but marine life was still there, and they were still ruining the ship's hull. So what actually happened was, various parts of solution were derived from different types of industries. So one, you saw Mr. Edison's electricity was definitely needed, but in a large ship and in away from all his generators, which were land based, we needed a solution, and still we needed Sir Humphry Davy's solution of cathodic protection, that is, using a sacrificial material which would take on the brunt of all the corrosion and still protect the material from marine life. So we needed that. Desired result was these two. So what really happened is the picture that you see right now. This is the modern solution to that problem. So as I was saying, 100 years later, this problem was solved with pipelines. It was introduced in pipelines and probably branded as cathodic protection. So they introduced all sorts of fancy gear and controlled the power supply much better, because that industry had matured, and now they could apply this solution back on to a ship. So this is what you would probably find in a modern ship, a cathodic protection unit with anti-fouling, as it's called, where a little bit of copper ions never did anything bad to the ship, but marine life it definitely got rid of, or put a permanent end to that. So you would not find marine life under the hull of a modern ship, and you would still find that the bottom hull is not corroding, because something else is corroding instead. So we are sacrificing that material to protect our hulls of the ship. So the point of this story is to convey that testing, first of all, if you go back to my story about Sir Humphry Davy, he tested it probably in the icy waters of North Sea, to me in hindsight, looks like he should have gone to Borneo or some tropical place and tested his idea, and on a real ship. So all this is hindsight. Hindsight is 2020. I'm not Humphry Davy, and Humphry Davy isn't here anymore, right? So we could have done that in warmer, where that's where the ships were, and that's where the problem was pronounced. And poor Captain Belcher had to report it back. To end the story, Royal British Navy decided that they are going to take away Sir Humphry Davy's solution, and they continued for 100 years with copper being corroded, and they would replace the expensive copper every time it was too much. So they would do that. They rather have the ship's performance, because in war times that was more critical than the removal of copper. So that would go down, probably written down as expenditure for the ship. So that's what happened with that. So we as design thinkers need to think about testing it in real customer conditions where it really matters. That's where you need to be going and testing your solutions, not in a very safe setup and which doesn't represent what your customer is. So that's the whole point of this long story. I would like to point you out to the quote that I have on the screen by Professor Matt Ridley. He says, human prosperity depends upon ideas having sex, combining together. The internet, by connecting human minds all over the world, can only accelerate innovation. So we need ideas from different disciplines, from diversity inside your team, and you combine all these ideas to get a very rich idea, and then take it to your actual customer place and test it out with real customers who are probably users, who are probably going to use it. And then you note down saying, okay, this is not working, this is working. So these are things that you need to be looking for when you go to your customer place or a user's place, where your user is. Okay. So I'm going to have a short puzzle for you. You have to guess what this is. This is a kid's puzzle, if you will, but has been a tremendous hit in my class. So I'm bringing this to you who are viewing this video. What is this? And you'll have to guess it as I go along. So the first clue that I'm going to give you is, say, let's say a customer survey group went and found out that, hey, it is white. So what are your ideas for, okay, now we know that something that we're looking for in terms of a solution is white in color. Well, yeah, some of the ideas are, yes, correct, some of you guessed milk, yeah, chalk, sure, walls, white walls, yeah, clouds, yeah, that's a good one. Okay, yeah, so many of those. So this could be infinite. I mean, there are so many things that are white. It's still not enough, right? So with one customer insight, you can't go along. So let's get another customer insight. Word is that this is the second customer insight. Oh wow, it has wheels too? Okay. So what is white and has wheels? Let me guess. Ambulance. Yeah, that's a good one. Ambulance. It's white and it has wheels. Yes. A cab, a taxi, a white taxi, I suppose. Yeah, that's a good one. Okay, so many more ideas like that. Good. So let's go on to the third insight. It has more than 20 wheels. Oops. So we started with cloud and teeth maybe and all that in the first insight. Then we came to ambulance. Now the customer insight says it has more than 20 wheels. Oh my god, what is white and has 20 wheels? A massive truck which is white in color. Maybe a metro train, yeah. Maybe a train itself, a white train, yeah, that's a good one. So now we are down to 3 or 4 possibilities, that's it, from the infinite that we had with just one insight. It travels fast, incredibly fast, I might add. Oh yes, you got it, some of you. Right, yes, that's a high-speed train, yeah, high-speed white train. Travels very fast, it has obviously more than 20 wheels. The fifth insight that I have for you is it runs on electricity. Oh yeah, definitely a high-speed train. We don't know for sure which country it is probably, so we need probably to run more insights and see more tests to see what kind of insights can we get. The sixth one, it carries people. Yes, a train for sure. It's not a freight train because it carries people. This is the sixth insight. It's a fast train, high speed train, and it runs in Japan. Oh, come on, it's a Shinkansen train. Yes, that was so obvious, blindingly obvious now. So with 7 insights, we started with clouds, walls, teeth, milk. Then we came down to ambulance. Oh, those were all wrong ones, right? We were actually shooting in the dark. We were so far away from the actual answer, right? So finally it says it runs in Japan. It's Shinkansen train is the solution we were looking for. It runs on tracks, yes. And this is the picture of an oldish Shinkansen train. It is much sleeker now with better designs by the Japanese engineers. So this is the answer we were looking for. Again, the moral of the story here is don't jump to solutions at the first insight itself. You need many more features or insights before you jump to solutions, before you arrive at a solution which is closer to what your user probably wants. And asking the user, it may help if they are already know or they are part of your team also, it may help. But trying to figure it out yourself is part of the fun, and yes, it's also part of your job as a design thinker. So now what do we need to test our ideas? What are some of the things that we definitely need before we can even start testing our ideas? Let's start with number 1, which is list of features. So what are the features, like what we saw in my puzzle, you have to define. You're describing a solution more than the solution itself. What features does the solution definitely have? So you need to list them. So that will be your item number 1, which is listing of features. All the features that you can think of, just list them. Next is also key, is list of assumptions. What have you assumed about your customer? You think they're very tech savvy, you think they have access to a road network around them, you think they have icy weather year round, or you think they have tropical conditions year round. These are some of your assumptions. Not saying they're true or false, but they are assumptions. You need to check each one of them to see if they are right or wrong. So that makes it the basis on which you can test your ideas. So that's list of assumptions for you. The third one is that you actually perform these trials or tests in the actual environment in which your user or customer lives or uses your idea or needs help, and that's where you're going to take your idea. You can do your tests in lab conditions, in controlled environment, but it has limited success or limited applicability. The actual proof of the pudding is when you actually go to their environment and do your testing there. That gives you far more insights and far more richer insights compared to what you would do when you're doing it in your own test conditions. So these are some of the conditions that you need, things that you need before you can set out to test. Next, what we need are prototypes. What are prototypes? They are things that you make with your own hand or represent on a piece of paper or make it using some building blocks, like make it cheap with a pen and paper, with stuff that is lying around, junk that is lying around, like used plates. What you can see on the screen are some examples of prototypes. In the software world, it could be wireframe drawings, as they call it, just representative sketches of what possibly could your user be looking at, your person who is going to use this look at. If it's a sort of service thing, it's a bank that you're designing it for, or you're designing it for a school, what would your interested person go through? What would their life look like when your idea is implemented? Is something for you to help imagine, as well as take it to your user and show them this is how it's going to be. And if you can make it large scale and they can actually traverse through this, nothing like that, chalk drawings on the ground, helping them guide through your concept, that also helps. All sorts of mock things that are cheap and easy to make will be handy here. I've seen people use aluminum foils, I've seen them use food wraps, boxes that are lying around. just trinkets that are lying around, and you can pull the rubber bands for tying them all together, whatever you can find, just to get what the idea represents. It's actually also useful to represent your idea within your own team, or you want to show it to another team who is also designing a similar concept, or so that they can understand and then come and say, oh yeah, we would have done this, and they can change that too. So prototypes are useful for many things. One is to showcase your own idea and showcase it to somebody else, show it to somebody else, or show it to your own user and see how they are doing it. So this is prototyping. There are courses out there on the internet about prototyping itself, so we are not going to do that here. But I would say start simple with a pen and paper, or if you are used to say on a PowerPoint or any of your favorite software, you can use that just to represent your idea, and it could be for anything. So the next is the field work that you need to be doing. So this slide has a list that you can look at in terms of field work. So the first step in that is to make a quick prototype of your idea and test it with your customers, your users. You can achieve that by sketching paper models, wireframes, role plays in front of the customer. So this is what I was talking about earlier. Now you need to take your prototype to the customer and observe how they react to it. So that is important, your observation, the customer actually interacting with the prototype. If you just show them the prototype and say, hey, how does this look? They're probably not to offend you. They'll probably say, yeah, this is a good job. Go on, make your product. Spend a lot of money on that. That's probably not proof enough. If they would interact with that and then you observe and find out, and preferably if you can even videograph or photograph their reactions, how they do it, with their permission of course, and you come back home and analyze what you've seen, what you've observed, and then take your call on what do we change in this, what worked and what didn't work with your prototype. That's probably better, ideal to in terms of prototyping and your field work. So this takes a lot of planning, effort, and interacting with their customers, probably with sometimes even with strangers, but it's worth its while. It's definitely worth it. We will show that to you in our demo section as well, which you have been following so keenly. So that will tell you how people have done it, and you can probably take tips from there as to how you can do this prototyping or the fieldwork part of it, prototyping stage. It is not a one-shot process, but it is an iterative process and happens many times over. So if you're interested, you can keep going back and forth and observe, and you can also go back to what I was describing as the 4 stages. You can actually go back, interview them, get some insights. You're empathizing with the customer with this new customer journey, and actually you can ask, so why did the customer do this? Why did the user do this? Why have they done this? You can do multi-why analysis, get a conflict of interest with your prototype, your new way of doing things, and your user, and find out what is the actual cause in which is causing them. So this is a multi-step process. Then solve that problem and modify that in your prototype. You can have multiple prototypes as well. I'm not stopping you from making multiple ideas into prototypes. It just takes a little more effort and a little more planning to do all this. So to begin, if you're doing this for the first time, I would urge you to make one prototype, take it to a few customers just to get your hands on with this process, and try it a few times with your friends, with people you know, then go on to people you don't know and get on started with it. So that's how I went through it, and I found it to be very useful. You can do it the same way as well. Just to conclude this whole thing, I am showing you an interesting picture of a fractal. This is called a fractal. It's an iteration. It's multi-cycle iteration, and in the end you will get a beautiful image like this, just made of iteration, something that you do over and over and over again, and you get this kind of a pattern. So good luck with testing. It's an exciting portion of design thinking, and of course the last one, but it needn't be the last one. It could be a great beginning for you. You can go back and make your next product, your next exciting product or next exciting service, and help somebody who needs the help. Okay, So, good luck and see you next time. Bye.